Okay guys, welcome to my class. Today we have iodoform reaction. Will help us to distinguish or differentiate ethanols or alkanols from ethanoic acid or alkanoic acid. Okay, this iodoform reaction is very important. So in our last class, we did something about the dehydration of alkanols using ethanol, where we noted or understood that when you dehydrate an alkanol, you are going to get alkanes or ethene in case of ethanol, and H2SO4 is liberated. So let us see the iodoform reaction. This reaction is very important because the reagents you are going to use to perform this very particular reaction is not stable. What do I mean that it is not stable? It is not stable in the sense that you have to prepare or synthesize the reagent. So the reason why sometimes we synthesize the reagent before performing a particular reaction or experiment is because of the nature of the reagent. So some reagents are freshly prepared before carrying out the experiment in order to avoid oxidation or any kind of reaction. So this reaction occurs in 3 stages. First, the first stage is the formation of sodium oxoiodate 1. And after forming sodium iodate 1, the second one is partially oxidizing ethanol, which is an alkanol, to give us their corresponding ethanol or alkanols or aldehydes. Then from there, we are going to react our agent, sodium oxoiodate 1, with the ethanol to now get our final product. So these reactions occur in 3 stages. So let's take it one stage at a time. So the first stage is we are going to synthesize sodium oxoiodate 1 by reacting iodine with sodium hydroxide. Of course, iodine is a gas. This is aqueous, to give us sodium iodide, which is a solid, plus sodium oxoiodate 1, then water is liberated. This is the first stage of the reaction. Iodine reacting with sodium hydroxide to give us sodium iodide, sodium oxoiodate 1, and water is liberated. This is the first stage. Then the second stage in this reaction is mild oxidation of ethanol or partial oxidation of ethanol. You have to oxidize it mildly or partially, not a complete oxidation, because if you if you oxidize ethanol completely, you are going to get ethanoic acid. Okay, but in this case we are going to partially oxidize ethanol. So we are partially oxidizing ethanol, OH, partially oxidizing ethanol. Look at what happens here. 2 molecules of hydrogen is removed from here, leaving us with CH3 CHO. So this is ethanol. Remember here, this is sodium oxoiodate 1. Sodium oxoiodate 1. And where this one is ethanol. So this is the second stage. Then the last but not the least stage is reacting this ethanol with this sodium oxoiodate, because this is the reagent we are talking about. So what do? We are having this one now, CH3 CHO plus sodium oxoiodate. Let's see the product of the reaction. The first product is CH, that is iodomethane, plus sodium methanoate plus sodium hydroxide. We can balance this here by adding 2 here. If you add 2 here, we've made sodium 3. So all we got to do is to add sodium 3 here. Okay, this one can also be balanced by adding 2 here. Sodium here is 1, 2. So we can add 2 here to balance the reaction. Hydrogen 2 hydrogen 2, oxygen 2, oxygen 1, 2. So I think the equation is balanced. So here, look at this compound. We all know this compound. This one is iodomethane, or you can call it 111 triiodomethane. That is the name of this compound. This one is sodium methanoate, and this is sodium hydroxide. So this reaction can be used to differentiate alkanols from alkanoic acid. When we get to that place, when we get to alkanoic acid, please do not forget this reaction. This reaction will help us to differentiate alkanoic acid from alkanols. So see you in my next class, and